Hi, I am Swayam and this is ACERT, my submission for Kestra Hack Week. ACERT is an advanced chaos testing tool for your microservices and apps that tests your services under different chaos conditions such as CPU stress, memory stress, network latency, etc. And it then tests your service under those chaos conditions and measures various factors like P95 latency, P99 latency, number of successful requests, number of errors, etc. by simulating virtual users. Thus, in the end, it generates a report of whether your service is safe to perform under load or whether the PR you are merging is degrading its performance. So, let me quickly take you through the architecture. See, it begins by cloning the GitHub repository of the URL that you entered. It then builds its Docker image, applies the deployment and deploys it on a Kubernetes pod. It then applies a node port service to expose it on port 3000. It waits 30 seconds for the deployment to complete and then it runs a baseline artillery test. So we just basically test how your service is performing without any load here. Once it's done, the run each chaos test task is called, which basically runs for each chaos test you selected, and it then calls the subflow, call general chaos subflow, which basically has a switch statement inside it. It performs the test on your deployment, then generates the artillery report from there, and once it's all done, it takes all those and sends it to analyze chaos results task. It then analyzes your reports and at the end it logs the summary of which tests have failed and how many tests have passed, and basically which test your service was not able to perform in, and it all depends upon the thresholds you have set. Let me show you quickly. So we are gonna perform it live on my GitHub repo. This is a test microservice that we are gonna test it on. Antidote Docker Hub username, password. Now here you need to select the type of chaos test you need to perform. You can select multiple tests, and there are dynamic fields here which will appear based on the tests you selected. Let's say I need to perform network latency, so the respective fields appear. So I'm gonna perform a pod kill test as well along with network latency. Let's set the latency to be 2000 milliseconds, correlation to be 70, and test duration to be let's leave it as default. You can select the chaos mode here. I'm gonna perform it on fixed number of ports, that is 2. You can select the threshold error rates and response time here, according to which your service will be judged. Here you need to enter the URL at which your service will be accessible, which is your node port IP and your node port and the port at which you exposed. Let's leave it at default and execute it. So while it's being executed, let me take you through the GitHub repo of the project. It basically contains the manual scripts that were used to build this project up, and these were the fields that were these contain the YAML files that are used to test your services manually, but it is very inconvenient, so Kestra helped there and made it all automated and orchestrated everything. Let's wait for the test to complete. here, as you can see, it creates a subflow. We can check it out. It's also running the respective tests. Here it is running the network latency test first. Okay, so the test has completed. It's gonna pause for about 30 seconds here. Okay, this is completed, and once this is completed, it now moves on to the next test, that is port kill test, and creates a respective subflow. And I can also show you the file this earlier flow outputted. This is basically the artillery test response that was produced, and this whole response is then analyzed at the end to judge whether your microservice performed well or not. Let's wait for the port kill test to complete. Okay, it's completed, and now at the end it is analyzing all the chaos results using a custom Node.js script. And here's the summary. So there were two tests, and one of the tests passed, but the network latency test failed. And if you want a detailed summary of what happened, we can check here, where it says there were total 300 requests, but only 276 were successful, and the error rate was 0.033, which was greater than the threshold we set, that is 0.0. The error rate satisfied, but the response time exceeded. The 960 milliseconds was greater than 500 milliseconds. That's why the test failed, and it shows here that network latency test failed. So this is the project. You can easily integrate it in your CI/CD pipelines, so that whether you want to check whether the PR you are merging is actually maintaining the performance of your microservice or degrading its performance. So that's it. You can check out the GitHub repo for a detailed analysis, and check out the flows here as well. Thank you.